Okay, this is 2017, number 4. If you thought bananas were bad, now we're talking about potatoes. I can't even. All right, at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. And the internal temperature of the potato is greater than 27 degrees Celsius for all times t is greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation that, where h of t is measured in degrees Celsius and h of 0 is 91. Okay, I don't really know what I read so far, but I kind of did a little bit. I've got a potato. Its temperature is 91 degrees when it's taken out of an oven. It never gets lower than 27. I'm circling the important stuff, so I'm trying to show you like how I would approach the problem. The internal temperature of the potato can be modeled by this differential equation where h of t is measured in Celsius and h of 0 is 91. So this should make some sense. H of 0 is 91. Yup, they told me it comes out at 91 degrees. So those two things match up. All right, let's see what they want us to do. So other than giving up, let's see. Write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. This is what I mean when I say, like, stay in your zone and just break it down into what you know. Like Krishna the other day was like, I don't know any of those words. You know, you were like, I recognize 5 of those words. Yep, because it's all such like gobbledygook. But we do know how to write an equation for a tangent line. So to write an equation for a tangent line, we need a point and we need a slope. So we want to know what the slope is at time t equals 0. So we need to find out what's the derivative of h, or what is dh dt, when time equals 0. So, wait a second. How can we find that? Oh, okay. So I was thinking like, oh gosh, we can't plug 0 into this. Right. We have to plug h into this, which is a temperature. So what's the temperature when time is 0? So the temperature is 91 degrees. So the slope is -1/4 times 90 minus 27. That is the temperature of the potato. No, I'm sorry. Woof. Okay, already tongue-tied. That is the rate in which, because this is dH/dt, the rate in which the temperature of the potato is changing when time is 0. We start at 90 degrees. So this value is -16. This is the slope. The point I'm going to use when time equals 0, the temperature is 91. So the point I'm going to use is 0, 91. So we're using time and temperature, time and h. So time and h of t, or t and h of t. So use this equation to approximate, or write an equation. Okay, I don't have much room here. But the equation is going to be y minus 91 equals -16 times t, or x, I'm going to use t, minus 0. Sorry, if it would make you more comfortable to use x, use x. So that final equation I'm just going to write up here is y equals -16t plus 91. There's my equation of the tangent line. And I need to approximate the internal temperature of the potato at time t equals 3. So let's just say, instead of maybe calling that y, call it whatever you want, it doesn't matter. I mean, it matters a little bit, but let's call it h of t. Okay, this is a tangent line approximation. This y value is the same as h of t. So we have to find what is h of 3. So I'm going to plug 3 into this, and I'm going to just cheat here and get 43 degrees Celsius. Whew, that is part A. You get 1 point for identifying the slope. 1 point for the tangent line itself, oops, and 1 point for the approximation of 43 degrees. So that's awesome. 3 points actually. And I think the hardest part was actually knowing what to put in for this and like getting an understanding of, oh, this is the temperature we need to find, not 0. Hi, I'm at school. All right, part B, use the second derivative to determine whether your answer in part A is an underestimate or an overestimate. So why do they want me to use the second derivative? Well, they want me to figure out what the concavity of that function is. Because if the function is concave up, whether it's decreasing or increasing, the tangent line would be below the curve. And if the function is concave down, then the tangent line will be above the curve, and the tangent line approximation will be an overestimate. So that's why they want us to find the second derivative. So if we're going to find the second derivative, here's my first derivative. So the second derivative is really just -1/4. The derivative of this is -1/4. That means the second derivative is negative. It means my function's concave down. It means my tangent line is above my function. So it means that, wait, what? Oh, poo. Hold on 1 second. Oh, you know what I didn't do? I didn't use chain rule. Poop on a stick. All right, hold on. Go back. See? Didn't even think about that. Crap. Okay, so our second derivative, let's see. So when I think about this first derivative, I think about this as being -1/4 h plus 27/4. So if I take the derivative with respect to t, the second derivative should be -1/4 times dh dt. Right? It's not dh dh. It's not like that I don't have to worry about it. I do have to worry about it. So, okay. So this is -1/4 times dh dt, which I have above, -1/4 times h minus 27. The time is 3. Let's see. I don't know the temperature of this potato when the time is 3. I just know what the estimate is. The estimate is up here at 43 degrees. But I do know that the potato will never be less than 27 degrees. So I do know that H will always be bigger than 27 degrees. So let's say it's 28 degrees or 27.1. That means H minus 27 will always be a positive number. So therefore, this entire expression will be negative times this is negative. I'll always get a positive out of that. I don't know what I'm going to get, but I'm going to get a positive number. That would be a great thing to go back and watch again if that didn't make a whole lot of sense. But the first thing I didn't realize or I didn't think about was when I take the second derivative of h, I have to chain on the derivative of h with respect to t. So therefore, I need to include -1/4 times dh dt. And then how do I figure out if this is positive or negative? Well, h always has to be bigger than 27, it says it in the problem. So if h is bigger than 27, this number, h minus 27, is positive. So therefore, this entire number is negative. Negative times negative is a positive overall. So that's a problem where you might run into trouble. Guess what? This is only worth 1 point for part B. But anyway, so now that I know the second derivative is positive, it means my function's concave up. It means my tangent line is an underestimate. And that is only worth 1 little teensy point. That's a kick to the gut. Okay, part C. This is where 5 points come into play. So this one's going to be huge. When you see this separable differential equation, you have to follow those steps. Separate the variables, integrate both sides, plug in the initial condition to find C and put it in, solve for Y. You have to go through all of those steps. Go back and look them up if you're not sure. So for T is less than 0, an alternate model for the internal temperature satisfies this differential equation. So they're changing the equation on us, where G of T is measured in degrees Celsius, and here's an initial condition. The original temperature is 91. Find an expression for G of T. All right, let's ignore the rest of it for a second. So the first thing I have to do is separate the variables. So I'm going to divide both sides by this and multiply both sides by dt. So I'm going to have dg over, I'm going to leave the negative on the other side just because I don't want it to get lost. And down here, I'm going to have g minus 27 to the 2/3. There, my variables are separated. I don't like this on the bottom, so I am going to write this as g minus 27 to the negative 2/3 dg equals negative dt. Okay, next step, integrate both sides. So the integral of this, because this is only g minus 27, there's no coefficient with the g, I don't have to use substitution. This is going to just be g minus 27, add 1 to negative 2/3, and get 1/3 divided by 1/3, or times 3. And this is going to equal, this is the antiderivative of negative 1 with respect to t, so negative 1t plus c. There's my integral of both sides. Next step, plug in my initial condition. So my initial condition is that when t equals 0, g of t is 91. So I'm going to have 3 times 91 plus 27 to the 1/3 equals 0 plus c. So c is going to equal 91 plus 27. Oh, this is for you, Connor. Is 118 to the 1/3 times 3. What's 118 to the 1/3? I'm looking on my little computer to see if they actually have an answer. What did I do wrong? Oh my God. Because this is subtraction. Whew. See, you're yelling at me, I'm sure. This is subtraction. So this is not 118. This is 91 minus 27 is 64. If you're doing a problem by hand and you end up with like 118 to the 1/3, that should definitely give you pause like it just gave me. There's no way they're going to have you take the cube root of 118. They're not interested in knowing if you can cube root crazy stuff. They're just interested in getting you to the problem. So the cube root of 64 is 4. So this is 3 times 4, so c is 12. Right, 64 to the 1/3 is 4 times 3. Yeah, okay. There we go, much more reasonable. So now let's take C and let's go back to my original solution, but let's replace C. So I have 3 times g minus 27 to the 1/3 equals negative t plus 12. I'm almost finished. My last step, it said find an expression for g of t. Well, I don't have g solved for yet, so I have to do that. So I'm going to have g minus 27 equals negative t plus 12, all divided by 3. Cube this entire thing, and then add the 27. Go ahead and do that more slowly if you want. So g equals that. Yes, I'm sure you could have it look a little differently, but that's basically the idea. So g of t equals that. And then what is the internal temperature of the potato at time equals 3? I'll be happy if I never see the word potato again. So g of 3, plug in 3. So negative 3 plus 12 is 9. 9 over 3 is 3. 3 to the third is 27. 27 plus 27 is 54 degrees Celsius. 5 points for this problem. So here's how the points break down. 1 point for separating the variables. Oops. What's happening? Stop doing that. Sorry. 1 point for separating the variables. 1 point for your integral. So both sides have to be correct. 1 point for both having a plus c and finding your c. So that's the same point here. You have to do both. 1 point for your equation for g, and 1 point for your final answer for g of 3. So 5 points. None of them are that hard to get. It's just a lot to put together. But whew, there we go. There's that problem.